Oh yeah. Oh yeah. It's like my farts. Silent but deadly. Oh yeah. Cruising at about 2,500 RPM. No clamp there, and it's leaking a little bit, so water's going through. Temp's been steady at 200, warmed up real fast. And man, this thing could not be running any smoother. A little rich at idle, but hey, that O2's working. Let's see. What I noticed is at idle, it's not pumping a whole lot of water through the manifolds. The O2 sensor side is nice and cool, but the other side is getting pretty darn warm. But if the RPMs are up just a little bit, it's happy. It doesn't get too hot to touch or anything, but probably something I'm gonna have to look at. The factory gauge is a little off, not too bad. Alternator's working. Yeah, it's going off now. Still a little warm though. This is cold. Alright, so quite a bit has happened since the last video. I got the O2 sensor stuff all figured out and working, and this is what I did. So this side I got done. I just had the engine running and it works. So what I did is I took my spacer from Crusader, cut it, machined it down, and I found that there were grooves right here that came out. It must be drains or something. I had to weld that up and remachine this. It was on all sides. So I did all that so I can seal it. I also found that the OEM gasket does not fit right here. It's too big. So I had to do a lot to get all of this to work. So what I'm going to use to seal it is put this down. This stuff here, it's freaking magic. It's what's used on the VR38 GTR engine. So even though it is exhaust and it's not high temp, I don't think it really matters with this because it does have water going through here. As we know, water, the exhaust comes out through here, water is coming up through here, which will keep all this cool. And as long as it's sealed real well right here and doesn't get in the engine, we should be fine. There's the O2 bung. Yep. Move this up. You see how the gasket is. See how the outer part of the gasket is too big for this guy, so it can't seal. Of course, why the frickin' hell would they make it to seal on the inside? It's just one of those things. When you're doing something like this, you're gonna run into problems like that. So my solution is sealant. I'm gonna run it for a while on it, see how it does. O2 and everything's on this side. I got everything perfect with it. I just had the engine running. It turned out real good. On the throttle cables, you can see there's a few different attempts to try to get this to work. I had to weld a bracket on the throttle body here. And then this is an OEM bracket that was on the original card. And I just took some thin plate here, bolted it to the intake and got that working. I thought that this worked in reverse from where the throttle had to go, because I tried to hook it up to the bottom. And if you look at it, if you run the cable through it, it actually connects at the bottom here. And that would make this work in reverse. So I was making this complex system with a wheel to turn it in the opposite direction. Then when I took a closer look, I'm like, oh shoot, you know, it's one of those things where it's a lot easier to actually do it than you think in your head. So it's kind of crude, but it's perfect. The throttles work nice and smoothly. It's good. I was looking at the rules here in Colorado, and even though this is a late model engine, Colorado is still stuck in the frickin' 1950s, and they look for some kind of like spark suppressor or fire suppression on the intake. So this is the original carburetor intake, and I just got a 5-inch to 4-inch 45-degree hose and stuck it on there, and that was pretty simple. So that should, you know, it's got a code on it. They're not going to know what they're looking at here, but if they're looking for like some kind of code for the spark or fire suppression, it's got what they need. So hopefully I won't hear any griping about that. That's about it. So, oh, I also installed fuel gauge. When I first tried to start this, it wouldn't start, and I found that the fuel tank had a check valve in it for the old carburetor setup. And the carburetor had enough vacuum to pull the fuel through, but these 044s, they can't do it. So I pulled the check valves out, got it to run, and just for emergency purposes, went ahead and put a cheap gauge on there. And I got the right fitting for this too, for the fuel rail. You know, just, it's better than clamps. So I just wanted to, since I had to redo it anyway, I made it right. And same on that side too, as you can see. So that's about it for that. Oh, so another thing I forgot about, so on the O2s, they pressed in the bungs, they pressed in perfectly. These were extra long bungs I got from, I think it was Glow Shift or something. Anyways, I used Loctite on the on both ends, and they were stepped. So they pressed in super tight. Like one of them, I was pressing it in so tight that I could see this bending a little bit as I was pushing it in. So on one of the manifolds, I had to pull it with a bolt on this end here. I had to use a banjo bolt that had fine, you know, this odd thread on it, and I'll pull it in. And then on the other side, I went the other direction and pushed it in. And in both cases, we had it tight enough around here where I could see this move a little bit until it gave way and had the press fit. And I think along with the red Loctite sealant, we should be good on that. I can't imagine that leaking even with nothing on it. It's such a nice tight press fit. And I kept it in a little bit right there, just so it doesn't get too hot. Because even though it's 700F Loctite, I worry that, you know, it could get to those temps pretty easily here in this, even though it's got water right here cooling everything, and the O2 bung is directly in the water flow. You know, it could still get hot, so I'll have to keep an eye on this and see how it goes. Just sitting out here, it's already starting to rust. I got to clean this up again, but anyway, you can see that that's what it takes to get an O2 in it. So hopefully the O2 survives and all this works. So another thing probably worth mentioning is I now have both of the, you know, Maricruiser / 305 alternators on it. Before, on this engine I had the LS alternator, and the reason I had to swap it out is because I burned up the regulator in the LS alternator by accident. The switched voltage is supposed to go into the LS alternator, so it's supposed to only be around 8 volts, but I had it hooked up to the 12-volt side on this, and killed it. It wouldn't run a charge. So I went ahead and just got another one of those serpentine belt pulleys that adapts to that alternator. Made that bracket for it, and it works perfect. So come out here and start it. So just it's always easy to tell when an alternator is working. So that's the voltage we're at now. Start her up. There we go. See, it works. So wasn't doing that with the LS alternator, so had to bite my lip and put the caveman alternator in there, but it works, so I can't complain about it. Plus, when it comes to inspection, chances are that they won't freak out over an automotive alternator being in there. It's at least got a boat alternator. So rest of the stuff I would imagine they're clueless about, but that's about it. All right, both O2s are in. Woo, that is close. But got it. On those studs, I decided to use studs because it's just a better way of doing it. I want to torque the shit out of this stuff to make sure it's nice and tight. So, you know, studs were the way to go. Plus with studs, what's nice is they were a little too long, so I just ground the bottom of them that goes into the manifold down so they were the right height. So that way I can have studs that fit everything perfect. So, you can see by the sealant, it's perfect all the way around. Hopefully that's the same on the inside between the exhaust and the water jacket. But this one I did the other day. I know it works. I had water run through this. No leaks, no problems. So I'm going to let this dry overnight and then test this one out tomorrow.